Hey, I'm Luisa van Uiden and I talk about the troublemaker, sea ice deformation during MOSAiC. The ones of you who participated in MOSAiC probably remember the various times when the opening of a lead or the formation of a pressure ridge forced us to relocate a part of the camp. Those events, as they are displayed on this figure here, did not only cause some trouble for logistics, but also had a strong effect on ocean, atmosphere or biological processes that we were capturing with our measurements. Since the consequences of deformation are relevant for many aspects of the Arctic climate and ecosystem, we do our best to observe them with satellites and buoys. Such a deformation field observed by satellite is displayed here. In green, there are lines of strong deformation, while the ice without deformation is displayed in blue. The MOSAiC flow is in the center of the 50-kilometer circle. Looking at those really well-defined lines illustrates that deformation varies often by 2 orders of magnitude on small spatial scales. For example, here a shear zone has crossed the MOSAiC flow and affected the processes at our measurement site, while most of the ice in the wider region remained unaffected. Since deformation events can have such a strong impact on the processes, we might need to consider where and also how often such an event took place before we can upscale the local measurements to a larger region. My aim now is to show you that the local deformation in the vicinity of the MOSAiC flow was representative for the deformation in the wider region. To do this, we will study this time series of divergence from the direct vicinity of the MOSAiC flow. All negative numbers refer to convergence, so the formation of pressure ridges, while the positive ones describe divergent events, when leads have formed. In the middle of the time series there is a gap, because then the MOSAiC flow was too high up north to be seen by the satellite Sentinel-1. Now we can add in orange the deformation time series from the surroundings. All orange dots represent deformation in the 50-kilometer distance. Doing statistics shows that the deformation time series of the MOSAiC flow was representative for the deformation of the wider region. On average, the MOSAiC flow experienced as many exceptionally strong events as the flows in the surroundings. However, the large spread of the orange dots also makes clear that this is only true looking at the whole time series and not for individual events. And as you know probably better for your own measurements, a lead in summer can have a completely different effect than a lead in winter. Therefore, it is possible to upscale the local measurements in respect to deformation, yes, but it is also important to take into account the effects of different seasons, times, and also the different scales. If you want to know more, for example, how we can use GPS buoys to increase the temporal resolution of the deformation time series and fill the gap, please pass by my booth just right after our session. I will also present lead opening rates and how we could connect those to ice thickness measurements to eventually find robust approaches to estimate lead fraction, new ice formation, and dynamic thickness change.